Hi, I'm Varun Krishna, and in this video, I'm going to show you how you can run an Agentic GraphRAG application for electronic health records on a single node using SambaStack. The GraphRAG application is built using SambaStack, LangGraph, and Neo4j. The agents in the LangGraph workflow use 3 different LLMs, and I'll show you how they can be run on a single node. You'll see fast model switching as agents invoke those 3 models in a workflow that queries electronic health records. And finally, we look at the 2 options for running SambaStack. One is on-premise, which is particularly important for applications with sensitive data like electronic health records that should ideally never leave your enterprise network. And there is the hosted version where we host the infrastructure and your applications can make inference calls over the internet. In Graph Retrieval Augmented Generation, or GraphRAG, a user asks a question that is processed by an agentic workflow that accesses data in a graph database. In our application, the agentic workflow is built using LangGraph and runs on SambaStack, and the data is queried using Neo4j's Cypher graph query language, which might leverage node embeddings to perform vector similarity searches. I'll demonstrate that in a bit. What's really cool here is that I'll be running a LangGraph workflow that makes use of 3 of the most popular open source LLMs, and we'll run all 3 on a single node with 16 sockets. To accomplish that, we need to create a model bundle, which is just a simple Kubernetes manifest YAML file that lists the models that we want to simultaneously deploy to a node. Note that you can bring your own checkpoints and deploy them in bundles. Once you apply the manifest, you'll get an OpenAI compatible API endpoint, and you can generate an API key that you can then use to invoke the models from within your agentic application. As the agentic application invokes different LLMs in a single workflow, those LLMs are loaded from DDR memory into high bandwidth memory. The switching happens extremely fast at runtime. The reconfigurable dataflow units that perform the inference operations live alongside the HBM and DDR in our 2-socket AI servers. 8 of those servers are packaged into a single node in a single rack, along with other good stuff like networking, storage, and CPU compute. Each node has 1 terabyte of high bandwidth memory that can hold multiple models depending on the model size. Now let's see all of that in action in a healthcare application. The application uses the Synthea dataset developed by MITRE, and it's been loaded into a Neo4j graph database. Here's a small sample from the database. There are a variety of different nodes and relationships in the database. Let's look at one node of patient Billy698. You can see his birthday and other information, including a few node embeddings that we will use to find similar patients. The neighboring nodes provide great context on Billy that help with retrieval augmented generation tasks. You can see that Billy has been to the emergency room a couple of times and has taken 4 drugs. Here's a visualization of the LangGraph workflow. There's a user input validation LLM that uses the relatively small Llama 3.1 8B instruct model. The main agent uses GPT-OSS 120B to select one of these tools to answer the user's question. If the user's question does not relate to one of the predefined tools, then a custom query tool invokes a subgraph that uses the Cypher agent to generate a custom Cypher query to answer the user's question. Cypher queries are similar to SQL queries, but they are for graph database retrieval, and the Llama 3.3 70B instruct model is capable of performing text to Cypher conversions. The main agent then synthesizes the tool results, prevents against hallucinations, harshness, and hate speech, and returns the result to the user. Let's see all of that in action running on a single node. SambaRAG switched between 3 different LLMs across 4 LLM calls on a single node in just over 2 seconds in total, of which under 1.5 seconds was spent on LLM calls. Custom Cypher was generated, and you can see the Cypher query here. Let's see which patient has spent the most on treatments. Wow, that's an insanely large number. What were his most recent diagnoses? Let's see if this can help us understand why his expenses were so large. It looks like poor Dudley is suffering from lung cancer. Notice that it took a lot less time to answer this question than the previous one because we only needed to make 3 LLM calls. We had a predefined tool to answer the question and avoid the cost of generating custom Cypher. How old is he? All right, he's 86 years old. Now let's find patients similar to him. This tool, Find Similar Patients, is a predefined tool that uses a node embedding for each patient to find the 5 most similar patients. As you can see, Dudley was 86 years old, and most of these patients are also quite old. You can also see that these patients have spent around $4 million across their treatments, and we'd seen earlier that Dudley had also spent around $4 million in his treatments, so that kind of justifies why these patients were returned as the most similar. This tool can also be used to find patient encounters, patient diagnoses, patient medications, etc. This application uses the chat SambaNova wrapper for LangChain that you can obtain from the LangChain SambaNova package. That allows you to seamlessly track all agent calls and LLM calls in LangSmith, as you can see in here. We also have integrations with several popular agentic frameworks that you can see in our documentation here. The application that I just demonstrated runs in SambaStack, which is essentially software and infrastructure for providing high-performance inference services. It comprises one or more Samba racks that contain SambaNova's AI-optimized GPU alternatives called reconfigurable data flow units, among other things. Even if an application can be deployed on a single rack, having multiple racks allows you to better optimize workloads that require high concurrency. The Samba Rack Manager provides tooling for customers to manage their own Samba racks without SambaNova's involvement. The inference platform supports Kubernetes deployment of services which allow you to deploy LLMs and bring your own checkpoint. Finally, the inference API is OpenAI compatible, making it easy to plug into third-party agentic frameworks, LLM ops platforms, and applications. Samba Rack can be hosted on-premise in a private or air-gapped network. This is perfect for applications with sensitive data like healthcare, finance, defense, cybersecurity, etc. SambaNova can also host SambaStack for you in our data centers, but you're still fully empowered to manage it. Your applications can make inference requests over the internet to endpoints that run on those systems. Please get in touch with us if you'd like to learn more, and thank you for watching.